Hello everyone, welcome to this video tutorial on FPGA programming. This is going to be lab 3 for ECE 3714 digital device lab, and this is your basis 2 board as you all aware, and it has 8 switches, 4 buttons and 4 7-segment displays, and it has 4 PMOD connectors. They are called as JA, JB, JC and JD. It has a USB output, a PS2 output and a VGA output. And this is the configuration of Spartan 3E FPGA chip. This FPGA chip is built by using something called configurable logic gates, and the Spartan 300 has 1920 CLBs, and each CLB contains lookup tables, registers and IOs, and each lookup table can make any kind of 4 input gates. Therefore 100,000 gates are possible. If you want to create a gates that has more than 4 inputs, LUTs can be combined to form gates with higher inputs, and this is shown in this figure. And now if you want to test your basis board switches and the buttons, what you can do is open Adapt software, select the test tab and press start test, and by this way you can check the switches. And as you all know, it has 2 configuration modes. One is the FPGA mode, as you can see here, and the other is a PROM mode. And for this lab we'll be using FPGA mode. Keep in mind, when you turn off your basis 2 board and again you turn it on, you need to reprogram the chip if you are in the FPGA mode. However, if you are in the PROM mode, you don't have to do that. And let's look at the configuration modes for FPGA mode. You need to have the jumper connected to PC. That's here. It needs to be under PC, and this is the chip you're going to write your programs, not PROM, directly on FPGA. And if you want to select a PROM mode, your programs will get stored here. This we are not going to do in today's lab. I'm going to send an email that has a user constraint file. Please save this in your computer because we need this file to run this week's lab. What is a user constraint file? User constraint file is just like a map. It has control input name and the actual pin number of the FPGA chip, and each of this is defined by using a text file. Like for example, if you look at switch 3 has the address B4, so it says input A. This is how we are naming, and the location of input A is switch B4, which is switch number 3. Similarly, input B location is K3, which is switch number 2. So basically we are going to define 4 inputs, A, B, C, D. So this you can think of as a variable name. You can think of this as a variable name. Please keep in mind, when you write your program, keep your variable names of inputs as A, B, C, D. Don't keep anything else because FPGA will get confused because you are defining it here as ABCD. and the output of your program, we are going to save it to a variable called win. And where it goes to M5. So what is M5? M5 is address of LED0. So either we call it a LED0 by a easy convenient name, or we can call it by using its address, which is M5. I am going to email the user constraint file for today's lab so that you can include to your program. And this is how we write our own UCF files. This chart has a pin address and the pin name so that you can write your own UCF files. And this week what we are going to do is we are going to create a digital roulette game. The rules of the game is very simple. If a player draws number 2 or 3 or a queen from any type of card, no matter what color it is or not flower it is, a player wins. So this is a very simple game. If any player draws 2, 3 or queen, he or she wins. So the input is going to be 2, 3, 4, 5, 6, 7, 8, 9, and for 10 it's J, it's for 11 it's king, and it's for 12 it's queen. That's how it's set up here. And if it's 12, which is queen, or 3 or 2, the output will be equal to 1. That means the player wins, otherwise it's not win. And we are going to create a truth table that has A, B, C, D, that are 4 inputs which you can give from a switch, and a decimal representation of A, B, C, D, and whether the player wins or loses. As you know, player wins only when you draw 2, 3 or 12, which is queen. And with this truth table, what we can do is we can deduce a min term from the truth table. Okay, what is the condition for win? The condition for win is this, which is 2. This is A dash, B dash, C, D dash, and then 3, A dash, B dash, C, D, and then 12, A, B, C dash, and D dash. So I put all these 3 terms under win. So this is going to be our expression. This is a very simple expression. If you want, you can try to minimize it even further by using Boolean algebra. And these are the design step process which we followed. We described the behavior, we created a truth table, we detected the equation, and then we are going to minimize it. And the last step is to create a circuit diagram. And in this week lab, we are going to do this in 3 different ways. As a first way, what we are going to do is we are going to create a schematic capture on your basis 2 board and then generate the test bench waveforms. The instructions for doing this is given in the lab manual. This is your part A. Your part B is going to be the same schematic capture. You will be transferring it to a basis 2 board by creating a bit file. These steps are again clearly explained in your lab manual. Please read it. And the last step is you will be implementing the circuit in breadboard. Please remember, we don't have many 4-input gates. We have only 2 4-input AND gates with the supplied chip bag. Try to construct the other AND gates by using 2-input gates. And this is how you connect, for example, A, B, C dash and D dash. If you want to connect this, and these are going to be your inputs. Call it A, B, C and D, and this can be controlled by these switches, and this is how we connect. Thanks for watching. Good luck.